about our work C-clip, contrastive image text encoders to close the descriptive-commentative gap. I'm William Theisen, and this is published with Dr. Walter Scheirer, and we are out of the Computer Vision Lab at the University of Notre Dame. My email address is at the bottom of the slide. If you have any questions, please feel free to reach out. So this work is based on some work we submitted to WACV last year, and this was focused on the idea of motif mining, or given, if we look in the middle box here, a large collection of unsorted and unlabeled images, how could we provide order to these images so that open source intelligence operatives could quickly sift through and understand large collections of social media data? So you'll notice here on the left we have some memes, and you'll notice here on the right we have some airplanes. And this is very useful to help understand trends quickly as they emerge in social media data because it's often unsorted. One weakness of this work is that it was only available for images. And so with this paper, we explore an expansion to the prior work based on multimodal data. And so most social media posts these days are multimodal in that you often have a piece of text and that text is combined with an image. And it's important to understand both the image and the text to get the overall message of the social media post. And as an example, we have here on the right a post from Arby's saying prepare ship for ludicrous speed. And it's an image of a meatball sub with meatballs spelled out in pasta sauce. And often what we were told last year is, why don't you just use CLIP, right? Really great multimodal model. Unfortunately, CLIP models, at least the out-of-the-box ones, suffer from what we would call the descriptive-commentative gap. And this is a breakdown of the models in their accuracy when you move from descriptive data to commentative data. Now, what is the difference here? CLIP models are trained almost entirely on what we would call descriptive pairs of images and text. And you can see an example of this down at the bottom. You have an elephant, and the text that it would be paired with is an elephant standing next to a tree in a field, right? It simply lists more or less the objects that are visible in the image. This is contrasted with what you'd often see in social media, where you have a herd of elephants in a grassy field. But the text that you're going to get with that is Kenya hails anti-poaching efforts and first wildlife census. And there's no mentions of elephants or grass or fields in that text. And yet this is what a positive match of an image-text pair of social media is going to look like. And if you dig into the embedding space of these CLIP models, you'll find that the text that is descriptive is actually separable from the text that's commentative, as you can see here in this image. Even though the images, right, of these elephants are not really differentiable by the model, the text itself is considered to be very different. And this results in a decrease in accuracy of CLIP models when applied to social media data. And this can be seen here. The top three models are what we consider our baseline models. And the first two data sets, MS COCO and XM3600, are what could be called descriptive data sets, right? Their image-text pairs are really similar to the previous slide, wherein the text is simply describing the objects available to the model in the image. If you have an elephant in a tree or in a field next to a tree, that's what the text is going to say. If you have a dog, the text might say, this is a picture of a dog on a couch. This is contrasted to common social media data, whereby you may have, say, if we're considering Russian Telegram, a blown up apartment building, and the text might be, I dislike Putin, right? There's no real connection between the image and the text without further understanding outside context in this pair. And so you can see here that when you apply these baseline models to descriptive data set, the accuracies drop drastically, right? If you look at the @10 retrieval on MS COCO, you're achieving 80% plus retrieval accuracies. However, if you switch to a commentative data set, these accuracies drop to somewhere around 20%. And this is a massive drop in terms of accuracy. And so in our work, we show that you can train these models on commentative text. And this results in massively increased accuracies on commentative tasks. Right? So not only does this gap exist, but we propose a simple solution to solving it, where you can train on commentative image-text pairs specifically to increase the retrieval accuracies on these downstream tasks. And what you can notice here is that, perhaps unsurprisingly, training on more data leads to increases in accuracy. And more discussion of this is available in our paper. But the important thing here is that this gap exists, and it exists across languages, and it exists across social media sites. And so a basic solution to solving this gap and enabling clip models to operate on social media data is to train them specifically on commentative pairs. Pairs of images and text where the textual description is not simply describing the objects in the images, but providing additional commentary on top of the image. Again, similar to what you would see on social media. And so examples of what this improvement in retrieval accuracy looks like can be seen qualitatively on this slide. So we have some query text, and we tried to match to it images related to this query text based on these two models. We have the baseline model, and we have our fine-tuned Clip2M model. And you'll notice here the images returned by the baseline model are really, we would call, quite irrelevant to the text that was in the original query. And we additionally provide the text that goes along with each of these images to add some future context, again, because oftentimes these are not in English. We provide translations. But you'll notice the Clip2M model, all 5 images are related to both the USSR and monuments. And you can see those words appearing in the original query text. So not only do these retrieval accuracies increase, right, but they increase in a manner that would allow open source intelligence operatives to much more quickly assess the online social media landscape surrounding an event, right? If you wanted to find images of tanks or missile strikes against Ukrainian apartment buildings, you need a model that understands this interplay between commentative text and images that would go along with that text, right? Rather than something that's simply looking for objects in the images. And it's important to use these models that have been trained specifically on commentative text for this task. This paper was more of an initial exploration of this accuracy degradation of clip models when you apply it to commentative situations. And so I'm interested to hear other options that those of you in the audience may have for helping to alleviate this problem. This is, again, sort of a basic exploration and an initial solution, but I think we can do better than simply fine-tuning on more task-relevant data. And please send me an email or stop by my poster if you have interesting ideas related to this discussion. Thank you, everyone, and enjoy the conference.